Now we start with section 5.3.2, the divergence in curl of magnetic field, and we will consider a general case. Now the general case is if we are having arbitrary charge distribution d tau prime. So the volume element is a prime coordinate, as we know from our custom in electrodynamics, and its coordinates x prime, y prime, and z prime, while the distance from the source to the observation point P here is tilted r, and the observation point coordinates are x, y, z. Like we will have the magnetic field B8R. The R coordinates are basically x, y, z. So we will start with the divergence in curl of this. First we will find the divergence, and then we will find the curl of magnetic field. We know that the magnetic field for the distribution of charge is mu naught over 4 pi. So mu naught over 4 pi in integral j, and j is in a prime coordinates j of r. So vector quantity cross r unit vector over r squared, and this is d tau prime. So this is the value, this is the equation of the magnetic field. And now we will have to keep few things in mind, that our r coordinate here, this is r, and r is a function of x, y, and z. Similarly, we have the so it's a function x and y and z, and then g is a function of x prime, y prime, and z prime. So g depends on the prime coordinates only. B is a function of x, y, and z. So B is a function of x, y, z, because we are finding the magnetic field at point P, which is having the coordinate x, y, z, and J is a function of the prime coordinates. If I want to have R, then R is basically the combination of x, the prime and unprimed coordinates, like x minus x prime and x unit vector, and y minus y prime and y unit vector, and z minus z prime and z unit vector. Similarly, the d tau here, we have d tau prime is dx dy and dz prime here. So this is all for our prime and unprimed coordinates. And now we will apply divergence on this thing. So the divergence of B, the divergence of P of R is, we will write here mu naught over 4 pi, and then here, and we will have the divergence of G, and now I will not write the R prime with this one, but G cross R unit vector over R squared and d tau prime here. Now if I look here, then it is utilizing a vector identity, and the vector identity is that we have the divergence. If we take the divergence of two vectors A and B, and they are as a cross product with each other, then this is equal to B dot del cross A minus E dot del cross B. So we have this identity. Now for our identity, let me write del dot and G cross R over R squared. This is B. B here is R over R squared dot del cross, and it is J minus B. Here is E, so E is J dot and del cross R over R squared. So this comes out like this, J dot del cross R. Now if I look here, what about del? Del depends on this R, so del is basically equal to partial over partial x in x and partial over partial y in y and partial over partial z in z here. So if I look here to this term, del cross J. Now del is this one and J is prime coordinates. So this one, the del means del cross J will go to 0 because it is depending on it is not depending on the prime coordinates here. So J is having prime coordinates here. This is unprimed coordinates. So for unprimed coordinates, this will be treated like a constant, and then it will have no curl here, no dependence here, and that's why we will have the J term equal to 0. And one terms remain here, and that is here, del cross R over R squared. We will have to calculate this one because here we see that R is a composite, it depending both on x and x prime, both the prime and unprime, it is depending on both. So it means we will have to calculate this one. So write this one del cross R unit vector over R squared. And if I take it the R component here, means from the curl I take the R component only, then this is 1 over R squared partial over partial R in R squared. And then the next term will be our this term. And now I will not write the R unit vector because I am already taking this as one component. So this is R2. Let's say I write this not only 2, but I write it as R to the power n, and I do calculate this one. So it will be for any power n, I am calculating this. So this is 1 over R squared and partial over partial R. And here this is R to the power n plus 2. And if I do calculate this one, then this is 1 over R squared and here n plus 2 and R to the power n plus 2 minus 1. So it will come out to be n plus 1. Now if here I specifically look for this one, then here the n is equal to minus 2. Because when this R to the power n, so it goes up, so R power is minus 2 here. So for specifically when I put this thing n equal minus 2, then plus 2, and it makes this thing equal to 0. So this means that the del cross R over R square here is also going to 0. And this means that when everything here becomes 0 in the integral, So we say that this implies that the divergence of B is equal to 0. And this is, we have written this thing in generalized coordinates, that the del dot D is equal to 0. So, one thing we have proved, and now we are going towards the curl of this equation. So, let's start with the curl of this. So, the curl of this equation will be del B there, and we take del cross B. And del cross B is mu naught over 4 pi. And here we have del cross and J cross R unit vector over R squared and D tau prime. So now we will utilize another vector identity, and that vector identity is that if we take the curl of two vectors which are being is a cross product. So this identity is equal to A dot A and then the divergence of B here while minus B del dot A and plus B, and we have B dot del in the A direction and minus A dot del in the B direction. So it's a very long identity here, and I write this for these terms here. Now, if I look here, that let me write this for my vector. Then del cross, and here is G cross R unit vector over R squared, and this is E is basically J, and this is the divergence of B, and B is R over R squared plus minus B here, and B is R unit vector over R squared, and divergence of, and this is E, so we have J here plus B, and B is R unit vector over R squared dot del, and this is an A plus, this is minus, E is minus here, and J dot del and R over R squared. Now if I look at this expression, then in this expression, what about del dot this one? So it is the combination of both prime and unprimed coordinates. So it means that this will be non-zero. We will have to calculate this one. If I look here, then divergence of G is a prime coordinate thing, so it is not depending on the unprime, and that's why this thing will go to 0. And when I come here and I look at these two results here, that what about this one? This del will operate, it's a dot product, and del it will operate on this one. So it means this is also equal to 0. And we are left with these two results here, which we will do calculate. So we are left with this one, J j of del dot r over r squared and minus j dot del and r over r squared. So now we have to find out this thing, the value of this. And when I see this one, in chapter 1 we have calculated this thing, the divergence of 1 over r squared, and that thing was coming out, the divergence of here from the component form is we did this thing, the divergence theorem, one side was giving us 0 while the other side was giving us non-zero, and we said that whether this is a problem with the divergence theorem or this 1 over r square function, and we came to know that basically that 1 over r square is having a singularity at r equal to 0, and that was the reason that its divergence was coming out to be, the divergence theorem was not giving the right result, and therefore we went towards the Dirac delta function. So that we have already found that this thing, this del dot r over r square is basically 4 pi delta cube of r minus r prime. If you remember this one, then it was equal to this. And the other thing that what will happen to this one, g dot del r over r squared. From our calculus trick, that this one we do like this, that if I write this thing in prime and unprimed coordinates, then minus g dot del r over r squared. This can be written, this is equivalent if I convert this, but it will become with a positive sign if I do convert j dot del prime and r over r squared. So if I do convert the del from the prime coordinates to the unprimed, or from the unprimed to the prime coordinates, it will cost me a negative sign, and we can prove this as well, but we take it as it is. And when I write instead of this one, and then I do integrate here this term, because it will give me one term, this one, and then plus this term on integration will basically go to 0, as it is having the 1 over r square term, and the r square term with the square of with the volume element, because here I am having d tau prime. So when I write the volume element in spherical polar coordinates, then this term goes to 0. And we are left only with the first term here,